Last time we developed the concepts of stability and Nash bargaining outcomes to use in predicting what happens in a network exchange experiment or just a network exchange theory. What we're going to do now is take those two ideas and put them together and actually use them to make predictions. So first let's develop a little shorthand for what we mean by stability and Nash bargaining. Let's say that an outcome is balanced if it's both stable and on every pair of nodes in agreement in the outcome, the values are a Nash bargaining outcome. Let's just look for balanced outcomes. That's what our theory is going to predict. Let's go back to that four-node path that we're dealing with at the end of last time and actually find a balanced outcome. That four-node path has exactly one balanced outcome. It's the one in which the nodes in the middle, B and C, get twice as much as the nodes on the end, A and D. So here the balanced outcome has A trade with B and C trade with D, A getting a third, B getting 2/3, and the same for D and C. Let's figure out why that's a balanced outcome, and it's good enough to just look at the AB pair. In the AB pair, first, remember what we're going to do is look for a Nash bargaining outcome between A and B. So we have to look at what A's outside option is. Well, A has no outside option in the deal with B. His value of his outside option is simply 0. B, on the other hand, has an outside option. If A and B don't reach a deal, B can go to C and try to reach a deal. But C is getting 2/3 in his deal with D, so B's outside option is only 1/3. The value 1 that B and C could get jointly minus the 2/3 he'd have to give to C. So B has an outside option of 1/3. That means the surplus that A and B can generate if they reach a deal is 1 minus the sum of their outside options, or 2/3. That's how much better A and B can do with the deal than they could do if they simply don't reach a deal and go take their outside options. So what are A and B going to get? Remember, the Nash bargaining idea is that each of them gets the value of their outside option plus half of the surplus. So A gets 0 plus half the surplus, or 1/3, and that gives A a total of 1/3. B gets the value of his outside option of 1/3 plus on the other half of the surplus, so B gets 2/3. So that gives us 1/3 for A and 2/3 for B in their exchange. Notice that the situation for C and D is exactly the same, right? C's outside option in the CD deal is to deal with B, and that gives C an outside option with a value of 1/3. So it's the same calculation for C and D, making this, in fact, a balanced outcome. It's clearly stable, and all the values satisfy Nash bargaining. That one's reasonably straightforward. Let's look at a more complicated example where we take a triangle of A, B, and C and we add an extra potential friend for A, node D. Question is here, what are the balanced outcomes? Well, it's pretty clear we should look for A and D to make a deal and B and C to make a deal. And if we do that with the values we have here, 3/4 for A, 1/4 for D, and a half each for B and C, we have something that's obviously stable. The question is it a Nash bargaining outcome? Let's start with the AD deal first. D's outside option is 0. He's got no place else to go except A. What about A? Well, he can go to B or C. B and C are both getting half. So the value of A's outside option is 1 minus a half that he would have to give to B or C to attract them away, so 1/2. That's A's outside option in the deal with D. That means the surplus in the AD deal is 1/2. So A should get his outside option of a half plus half of the surplus, which is 1/4, and A should get 3/4. D should get the rest, which is 1/4. 0, his outside option, plus half the surplus, 1/4, and it gives him 1/4. So the AD deal satisfies Nash bargaining. What about the BC deal? Well, we could go through the calculations, but actually that one's pretty simple. B and C are in completely symmetric positions. They can deal with each other, or either of them can deal with A. Now, in the deal with A, the value of that outside option would be 1/4, but it doesn't really much matter what it is. It's the same for both of them. So they're each going to get a half. They're going to share their value of 1 equally. They each get a half, and that half is the value we used in computing A's outside option to his deal with D. Remember, this is all determined simultaneously. And we have a balanced outcome. Stable plus satisfies Nash bargaining. And more or less as you would expect, A does well. A should do better than B, C, or D, and he does. He gets 3/4. You would expect B and C to do better than D because B and C have other potential partners, here A, and so they each get half. D is the one who gets the least because D has no other potential partners. And very importantly, his only potential partner, A, is very strong, and that makes D very weak. Okay, that's the theory. We could use it on more complex networks, but rather than go to something very complex, let's use it to talk about a simple story. Let's make this a little more applied and make it a little more interesting. Let's suppose that you have a brand new iPad sitting in the box, never been used. Perhaps it was given to you, and you don't want it. Perhaps you already have an iPad or something else. You don't want this iPad. You have absolutely no use for it. It's worth nothing to you. But you have a friend who wants a new iPad, and that friend is willing to pay, if they have to, $400 for a new iPad. So let's have you as a node, your friend as a node, an edge between you, indicating that you can exchange. And that exchange would generate a value of $400. The iPad you have is worth nothing to you. It would be worth $400 to your friend. So we've gotten away from a value of 1. We just made it 400. Your friend, of course, could alternatively buy a new iPad from Apple. Let's make this story really simple and imagine Apple has a new iPad that's just come off the production line. They've got this one and only one iPad sitting there, and they're willing to sell it. Apple wants $400 for it. And Apple has a lot of potential buyers. Here we have buyers 1, 2, and 3, plus your friend. Each one of these buyers is willing to pay $400 for an iPad if necessary, and Apple has edges to any of them. It could trade with anybody. Question is, what's going to happen here? What will the trades be, and what will the prices be? Let's start with Apple first. That one's pretty easy. Apple is a little bit like the node in the middle of the 3-node path, right? It's got lots of potential partners, none of whom have any place else to go. At least buyers 1, 2, and 3 don't. So what's going to happen in the deal with Apple and any of those buyers, let's say buyer 3, is there will be an exchange, but Apple's going to get all of the surplus. Buyer 3 is going to pay Apple $400 for the iPad. Buyer 3 is going to get the iPad. Now, buyer 3 got something he wanted. He got the iPad. He was willing to pay $400 for it, and that's actually what he had to pay because Apple could alternatively have sold it to buyer 1, who currently is not getting an iPad, and gotten $400 from him. So that part's easy. But that tells us what's going to happen with you and your friend. Your friend's outside option to dealing with you is to deal with Apple, but Apple's getting everything in its deal with its buyer number 3. It's getting $400. So it's not going to make a deal with your friend unless it gets $400. That means the value of your friend's outside option in dealing with Apple is actually 0, right? It's going to be the whole value of $400 minus what Apple needs for $400, giving that value 0. So neither you nor your friend have any outside options, or at least you have nothing with any positive value. If you reach a deal, it generates a surplus of $400. If you have no outside options, the Nash bargaining outcome is you each get half the surplus. So you each get $200. So Nash's prediction here is that you sell your iPad to your friend for a price of $200. You get the $200, your friend gets an iPad that he would have been willing to pay $400 for a price of $200 instead. You both get some benefit, you share the surplus. Notice what we've done here is we've taken the network exchange idea and applied it to really a buyer-seller network. And this can be done for far more complex and actually far more interesting networks.